Hi everyone, and welcome to Down to a Science. Today we're going to talk about pressure. We're going to talk about atmospheric pressure and internal pressure. Atmospheric pressure is the pressure pushing in on something. So like this balloon, there's pressure pushing in on every side of the balloon. And then there's internal pressure. Internal pressure is the pressure pushing out on the balloon. So when I blow it up more, I'm adding more internal pressure, which means there has to be more external pressure. Let's look at some more examples. For our first example, we'll use an egg and a bottle. I asked for my assistant to come over. First, what she's going to do is take birthday candles and stick it into the egg. Once we get the candles in the egg, we'll use a match to light them up. Once the candles are lit, we'll put the candles in the bottle and tilt the bottle upside down. Now we wait for the candles to blow out. As the candles blow out, all of the oxygen is removed from the bottle, which creates a lot of atmospheric pressure around the egg. As the atmospheric pressure increases on the outside of the bottle, but there's no pressure on the inside, the egg pushed into the bottle. The hard part is trying to get it out.
Hey, who put my lunch in a bottle?
I don't know. Who would put your lunch in a bottle?
I don't know. It's gonna be hard to get it out, though.
Try blowing on it.
Okay. That worked. It did.
Let's look at our second example. Here we'll look at atmospheric pressure. I asked that my assistant come to help. Here we have an ordinary pop can. In the pop can, I've put a little bit of water and boiled it. Boiling the water gets the oxygen out of the can. Now what we're going to do is we're going to grab onto the pop can with our tongs and our glove. We'll flip it upside down into the cold bath of water and see what happens. So now that we've flipped it upside down into the water, we see that the can has been crushed. The crushing of the can occurred because the atmospheric pressure was greater than the internal pressure. We've already seen the effect of atmospheric pressure on a regular pop can. Now let's see the effect on a much bigger can. I've added a little bit of water to this can and I've heated it up, allowing all of the oxygen to exit the can. Now here I have a nice cold bath of water. If I take this can and flip it upside down just like I did with the pop can, it should work. Let's see what happens. As you can see, there's a little bit of a dent in the can, but this is much thicker metal, so we might have to heat it up a little bit more. Let's look at our third example. We've already looked at how atmospheric pressure can push on an egg and get it sucked into a bottle. And we've even looked at how pressure coming into the bottle can push the egg back out. Well, let's look at atmospheric pressure in a different view. Here I have a mason jar filled with water. And here I just have an ordinary cue card. If I place this cue card around the mouth of the mason jar, and I flip it upside down, the atmospheric pressure pushes back on the card, allowing the card to stay in place, meaning the water can't get out. Let's look at another example. We've been looking at atmospheric pressure and how things can push in and how it pushes on top of us. Let's look at an internal pressure example. I'd ask that my assistant come over and help. Here we have a smoke machine. And what my assistant has is a cannon. This cannon will create smoke rings. So let's put the open end on the smoke machine, create a little bit of smoke, and let's make some rings. As you can see, when he increases the internal pressure of the cannon, it makes the smoke push out, and it makes rings.
Okay. Look, I found another one. Well, that was fun.
So now that we've looked at one experiment with internal pressure, let's look at another one. Here, I have a bottle filled with methanol gas. I've stoppered it with just a rubber topper, and I'm waiting for the methanol to evaporate. Here, I have a generator. I'm going to try to generate 5,000 volts of energy, of electricity, through my bottle, create a spark, and hopefully show the internal pressure that the gas has built up. Now that I have all the wires hooked up, and my liquid has been in there for quite some time now, let's take a look and see what happens. As you can see, the internal pressure of the bottle was so great that it shot the rubber topper right out the top. Isn't that awesome?
Was that all? I was expecting a bigger bang.
Oh, so you want more?
Yes.
So what I have here is a water jug. I've increased the size of my little plastic jar. I've filled it with some methyl alcohol, and I've created a spark on the inside. What I'm going to do is I'm going to put a stopper in there. I'm going to take a Kleenex, just so I don't lose my stopper. I'm going to make sure it's in there nice and tight. I'm going to shake up the jug a bit to make sure everything's moving around. Make sure all my gas is produced. Now that I've produced enough gas, I'm going to hook up my wires. For those of you who are wondering, this is almost an example, or a very close example, to little gasoline cans that you fill up. If you don't put the gasoline can on the ground when you fill it up at the gas station, then there's a very good chance that when you get back into the car or reach to grab the gas can, that you might produce a shock. And if you produce that shock when touching the can, there's a very good chance that the internal pressure might give way. So let's take a look. So as you can see, the pressure was so great that it pushed the stopper right out the top. Now wasn't that awesome? We've looked at some great experiments so far this episode. We've looked at external pressure, atmospheric pressure, and we've looked at internal pressure. But you know what? I always love to end with a bang. So we're going to end with internal pressure. Here, I have water. In this beaker, I have dry ice. When you mix the two together, you simply get carbon dioxide formed. What if I put them into a bottle and I cover it? So here I have a milk crate. This is going to act as a protective shield because this experiment is really dangerous. So don't try it at home. There are plastic shards and covers that go flying everywhere. So this milk crate is my safety feature. I'm also going to be wearing a headset or headphones so that I can save my hearing. So let's have a look. Are you ready? Lots of pressure. Lots of pressure. Wow! Wasn't that amazing? All of that internal pressure built up inside of the bottle, and it just tore it apart. This is what's left of my 600 milliliter bottle of Pepsi. Just shards. So remember, don't try this at home, because pressure can be dangerous. So just to recap today, we looked at external pressure, which is
When the air outside is pushing on the object.
and we also looked at internal pressure, which is
When the air, or when the object is pushing out against the air.
so those are the two pressures we saw. External pressure and internal pressure. I hope you enjoyed today's show, and I hope you enjoyed the experiments. Thanks for watching Down to a Science, and we'll catch you next time.
These quizzes are so hard. There's so much pressure.
Hard and place it around the rim of the mason jar. I'll flip the mason jar upside down, and hopefully the atmospheric pressure will hold on to the card. Hopefully. Freezing cold bath of water. And he's going to take it and he's going to... Remember the practice part over there? Remember the practice over there? So you didn't touch the can.